Good morning. Oh my God, everyone's waking up from Universal, right? How many people went to Universal? Do you have a good night? Yes. So how many people have been to my previous sessions? Oh, wow. Oh, wow. So it looks like most of you. So my name's Chris Testa-O'Neill. And today what I'm going to be taking you through is data loading best practices. And over the course of the last 3 days, for the last 5 days we've been here, haven't we? That's right. Over the last 5 days, I've taken you through 3 other presentations that's looking at modern data warehousing in the context of relational, non-relational data stores with Synapse Analytics stroke SQL Data Warehouse and orchestrating that through Azure Data Factory. Now, the intention of this particular presentation is to home in on data loading best practices. Now, before we look into that, we need to just give a quick overview of Azure SQL Data Warehouse. Why have I moved back to Azure SQL Data Warehouse and not talking about Synapse Analytics? I read through your feedback, which was extremely valuable. Thank you very much. And there's a few concerns from people who've been attending my session saying, hey, we've got investments in Azure SQL Data Warehouse already. I'm concerned about how this is going to impact our existing investments. What should I do? So let me make the message loud and clear for you. Anything you've done in Azure SQL Data Warehouse will work in Synapse Analytics today. I appreciate the thumbs up there. So let's calm you down with that, right? The underlying engine for Synapse Analytics from the relational perspective is based on Azure SQL Data Warehouse. The key thing, as you heard from Rohan and Satch's announcement, is the integration of relational and non-relational big data stores. What I'd like to do is home in a little bit on what the underlying architecture of Azure SQL Data Warehouse is. Well, effectively, here are the core benefits if you've never used it before. It's platform as a service, which means that you only have to focus on the data. You don't have to worry about patching. You don't have to worry about virtualization or anything like that. PaaS services give you the ability just to purely focus on the data itself. The biggest advantage of this is the elastic scale. The fact that you can scale up your Azure SQL Data Warehouse for busy periods and scale it back down during the quiet periods. This means that you're in complete control of your costs and choosing the appropriate capacity for when you need it. It's a big data relational store. I've walked around the group, so for people who've been following me, you know that I try and walk and ask as many questions of the group as possible. The fundamental architecture of this is different to Azure SQL Database. There's a reason why Azure SQL Data Warehouse can scale way beyond SQL Database. So we need to understand how that architecture works because that has a direct impact on your data loading best practices. Pause and resume, one of the best features. You don't want to use the compute, pause it. The costs are stopped right there from the compute perspective. You still have to pay for the storage. You're just pausing the compute, so you're not paying for that. Separate storage and compute, which basically means that you can keep the data separate from the compute itself. That's what gives us the ability to pause. And finally, you can control the workload management through resource classes, giving higher priority to certain workloads compared to others. Any questions so far? So this is the underlying architecture of Azure SQL Data Warehouse. Basically, you have on the left-hand side of the screen the control node. And this is important in orchestrating the activities that occur from the compute nodes beneath it. So the way this works is that a query will come in. The control node will distribute that query to the compute nodes, which will do the processing to return the result back to the control node. So effectively, you've got 2 layers here. the control node, which is effectively the brain, and the compute nodes that provide the muscle in processing that data. So this is a distributed data processor. Now, there is a process with this where you will provision an Azure SQL data warehouse. You'll then load it, and then once you've loaded it, you'll query it. And I'm going to show you how you can do that from T-SQL so that you can appreciate what the value of Azure Data Factory is when using ADF to load data into Azure SQL Data Warehouse or Synapse Analytics. Any questions about the architecture so far? Because it's really important that you understand that. Okay. Loading design goals. They're no different than they were if you had an on-premises data warehouse, right? Ultimately, you're trying to load data as efficiently as possible. It should be non-obtrusive, it should respect concurrent queries, and basically, it should be done in a way that maximizes the opportunity to load the data at times where you can really ramp up that performance. The other thing that you need to take care of as well is that there are factors that can impact the performance, such as table fragmentation. Loading can actually reorganize the data so that table fragmentation is reduced. There's also recovery capabilities built into this architecture so that if there is a data load failure within a node, it's basically handled by the rest. Now, the biggest point we see when it comes to customer support in this area is with Azure SQL Data Warehouse, there are multiple methods to load data. And sometimes our customers use the wrong method to do it, right? So you should really come out of here today with a very, very clear idea of what is the preferred method for loading data, and ultimately, what are the tips and tricks within that preferred method to make your data loads go even further. So here's a reminder of the architecture that we've been discussing all week. For the benefit of people who were not here, on Monday, we looked at a holistic overview of this architecture and how it relates to the announcements that were made. You'll notice that I've gone back to the Azure SQL Data Warehouse. Again, this is to ease the concerns of people from the feedback I got, but you could replace that with Synapse Analytics. So on Monday, we looked at the ingestion and the transactional loads and how that could be placed into Azure Data Lake Store. On Tuesday, we looked at Azure Data Factory, and that went into Wednesday, where Tuesday was spent on ingestion and Wednesday was spent on on transformations with the mapping data flow task. And today we're focusing on getting that data from an Azure Data Lake Store and loading that into Azure SQL Data Warehouse as much as possible. Now, effectively, you have a number of different methods in which you can load this. Bulk copy program, SQL Server Integration Services, but the sorry, stumbled on my words there. The preferred method for effectively and efficiently loading data into a data warehouse is PolyBase. How many people work with PolyBase in this room? Oh, I'm so glad I asked. This is going to be so important then. How many people are using SYS? Ah, okay. So for don't panic, right? Let's get you to a place where we can get you from SYS to PolyBase. Does anyone use bulk copy program? Yeah. Are you kind of experiencing slow times with the SYS and the bulk copy? Yes. Maybe, okay, hopefully we can explain how this works. The reason we should be using PolyBase is for this. It leverages that massively parallel processing architecture. Remember, we talked about the data warehouse being broken down into two layers. The compute layer, which is the brains, and the control layer that is the brains, and the compute layer that provides the brawn. The compute layer is effectively the massively parallel processing architecture, right? It gives the ability for PolyBase to make use of all the available nodes within your data warehouse, which will load and export data a lot faster than SYS and BCP, right? I've been involved with customers where, you know, they've gone into Azure SQL Data Warehouse, consultants have gone in and loaded and set it all up, and everything's worked, and then over the course of the year, it's progressively got worse. And the reason why it's progressively got worse is when they had problems, instead of looking at the PolyBase, they sidetracked it with SYS. Next thing you know, we're getting a call going, this is taking days, you know, and then we go in and go, well, why are you not using the PolyBase course, the code that the consultants gave you? Well, we don't know that, but we know SYS. So sometimes it's just worth making a little bit of investment in understanding that. The second key benefit, as you would have seen in Wednesday's presentation, is the fact that there is Active Directory support. And you're going to see a lot of code today, and the reason why, it's not a lot of code, but I'm deliberately showing you code because I want you to see the various components of PolyBase at work. But once you understand that, you realize how valuable Azure Data Factory is with its click and a couple of options, and then you're done. It saves so much time. And the other thing to note with this is that it does support a wide variety of file formats, right? Compressed delimited text performs the best, I find, but there's nothing stopping you from using ORC or Parquet or Avro. So there's a wide range of file support there. And what you're noticing here is I'm starting to talk about files. And files become really critical to the loading strategy within Azure SQL Data Warehouse or Synapse Analytics. So there are three components of PolyBase that you need to be aware of. The first one is an external data source. This provides the information to point to where your data resides. And this is typically in a blob store or a data lake store, right? With the data source defined, you then define what's called an external file format that provides PolyBase with the definition and structure of the files that you're going to be loading. So, you know, what are the text qualifiers, what are the comma delimiters, what is the new line feed, how is the data structured. With that information, both the external data source and the external file format, basically PolyBase is able to use a CTAS statement, Charlie, Tango, Alpha, Sierra, which is an acronym for Create Table as Select. It uses that statement to run against the external data source, the file format, in order to create your structured table within the actual data warehouse itself. So the first loading best practice is for massive volumes of data to be loaded, you should use PolyBase. You should use PolyBase. Don't get me wrong. If you're using SQL Server integration services to load a couple of megabytes, yeah, it could be bigger than that, to be honest. It can be hundreds of megabytes of data, and it's done infrequently, I'm not too worried. But I'm on about the regular shifts of data. The other thing I would say as well is even if it's only a couple of hundred megabytes of data, I do feel it's best to get into the good practice of PolyBase so that if you do have an unexpected spike in data, you're there and ready to do it. But just as much as PolyBase is the first loading best practice, there are tips and tricks within PolyBase itself that I think you should be aware of to really make your PolyBase loads go lightning quick. Let's have a look at the first one. 1, manage your files. It is better to split one big file into the same number of compute nodes that you have, 6 is the maximum, than to have one big file being processed. How does that look? In this example, we have one big file, and what we do is we take it and we split it into little files so they can be processed by each comport node. That is how you get your parallelism. Does that make sense? Number 2, try and reduce concurrent access to the server. If there's people on it, it will be slower. But this is not rock, you know. Anyone who's done data warehousing, even on-prem, knows that anyway, okay? But do it at times when it's quiet. Number 3, create a dedicated load user account for the process of PolyBase. This means that you can have a user account, that you can create a resource class that can be assigned to that, which basically means that if that process runs, it is assigned more resources during that process, okay? So it's another way to circumvent concurrent access. The downside of it, of course, is that your users start to complain that this is really, really slow, yeah? But again, it's all about compromise and balance sometimes. Manage singleton updates. This PolyBase is at its best if it's doing a mass batch update. You know, I'm not too worried if you're getting the odd statement coming in and being processed, right? It does become a bit of a problem where you start to see loads and loads of different singleton processes coming through, and it's just starting to overwhelm, because that's not good use of the parallel system. The tip here is probably you'll want to manage those singleton updates so that you can group them together, batch them up in a file, and then let that file process across all of the compute nodes. Now, like I say, if it's a singleton update a day, I'm not too worried. But if it's getting to the point where really you're getting a lot of individual updates or inserts and that occurring, that becomes a problem. And it's not really what this was designed for. If you want to kind of treat it as a transactional system, that's where you go to Azure SQL database, quite frankly, and figure out a process to make it a transactional system to get it into data warehouse for your reporting and advanced analytical scenarios. For those of you that do use PolyBase, are you doing any of this at the moment? No? Some useful tips here for you. Okay. Optimize your loads. I think you've got to kind of view this as a two-stage process. Now, one of the things we'll cover in the next session is the different table distributions that you have. I'm not going to go into in depth now, but all you need to know for the moment is that your first step using PolyBase is probably just going to be a straight load into staging tables. Now, in the next session, we're going to learn something about round robin and hash distribution. And I'll tell you why sometimes it's better to load staging tables with hash distribution. The default is round robin. It'll mean nothing to a lot of people at the moment, but I want you to hold that thought for an hour's time. Yeah, can you believe? I've got a presentation here, then I've got to go run all the way to the other end to do a presentation at 10:20, to run all the way back here to do a presentation here. I'm going to get a segue, I think. I digress. But you got to think about how you break down the load process, because doing it in a round-robin distribution is the fastest loading method you can use, right? And anyone who came to my previous sessions, what's the most important thing when you're grabbing and collecting data? What did I say is the most important thing? Can anyone remember? Do not impact the production system, or impact it in minimal a way as possible. Because at the end of the day, that production system could be earning your organization revenue, or it could be supporting operations and so forth. So hit it into the staging table first, and then place it into your production tables after. But there's a couple of variations that we'll look at that for query, for performance tuning later on. And finally, create statistics after the load. Why? Statistics help improve the actual query performance itself. Okay? That's it. These are the tips that you should be using when using PolyBase. Use PolyBase first. Think about dedicated load users. Think about managing your files. Think about resource classes to prioritize your workloads. Yeah? Think about a two-stage process for loading the data. Definitely add statistics after the load is complete. Okay? So what we're going to do now is look at this in a demo. Happy with that? Great. So I'm just going to go into the portal. And I shall go to the resource group called CTO Ignite. And in this demonstration, what we've got is a storage account called CTO Blob Store. And in here, we are using a container called Landing Zone. And then we've got an Azure SQL Data Warehouse instance with a database called Demo DW. And if I use Storage Explorer, let's take a look at the contents. Just wait for that to load up. We can look at it here and now. I don't need to go into Storage Explorer. So basically, we've got a list of products in there. Now, effectively, before I joined Microsoft, I used to work for a company that was a retailer, and their product updates were going into the millions every day. Okay? There were updates being done to the product catalog every day. So basically what we're going to do here is start off by saying you'll want some mechanism to place your data in a file structure, yeah, within your blob or your data lake store, right? And we did that with what activity on Tuesday, please? What did we talk about on Tuesday? Yeah, the copy activity, yeah? But what I've done is, because I gave you a demo of that, I've just put the file in already because we know the copy activity can do that. I'm going to show you now the T-SQL code that will be required to load this in PolyBase, so that for those of you that did see the Azure Data Factory, you'll kind of be grateful for how much time it saves. Now, the way we'll do that is by using a SQL Server Management Studio. and we'll connect to the SQL Server instance. Did someone just die there? Okay. So we'll just give it a minute to log in. A little bit slow this morning. Okay, let's sign in. I will tell you at the end of the session. Let me get through this. But thank you so much for asking. It would have been a good way to pass the time, but you know any minute I'm going to be able to sign in and do it, but I will give you an update right at the end. Let's just say I work for an amazing company, as you will find out at the end. So it's a little bit slow this morning, so I'm going to apologize for that. I'm not sure why it's slow, but what I'm going to do is I'm going to sign in, and then I'm going to basically put the firewall access so that this client can actually connect and talk to the SQL Data Warehouse instance. And then what I'm going to do is I'm going to walk you through the various components of PolyBase and how that works, okay? Now, the first thing you might want to consider, if products.txt is a massive file, then probably what you want to do is have some kind of process to break those files down into multiple files. Now, for example, if you choose the highest level in Azure SQL Data Warehouse or Synapse Analytics, that is actually 60 compute nodes. So you could break it down into 60 files if you went for the maximum size. Just still waiting for this to go in. I'll be patient. People know how to create a login and a user in SQL Server? That's no different. Create login, create user for the dedicated account. I've already got my dedicated account already. It is very slow this morning. Oh, it's saying I'm not signed in. I thought I did sign in. Okay, so I'm signed in. Click on OK. Perfect. So we'll just give it a minute. Okay. Great. So within here, we have the database called demo.dw. And what I've done is I have created some of the queries already. And just to be really super safe, I'm going to create the query here. Right. First thing you will want to do is create a master key. This is done at the database level so it can protect the credentials that are used to authenticate against your data store, be it Blob Store or be it Azure Data Lake Store. This is not specific to PolyBase at all. It's just the security thing that you will do in the movement of data to external data stores. Now, what we're also going to do is create this credential. But before I do that, I want to make sure that within the Blob Store itself, that I'm using the correct access key to provide the authentication to that store itself. So just to be doubly safe, I'm just going to load this up in the portal, copy that access key, and then place it within the credential code. So access keys. key. And then let's replace that. Perfect. So, note the name. The name of this credential is called Azure Storage Credential. That's going to become important now. The reason why it's going to become important is because we use that storage credential there to have a connection to the blob store in this case, to the container called landing zone, and we wrap that up in what's called an external data source called Azure Storage Product. The important thing to note here is that we see that it's using the credential Azure Storage Credential that we've just created up here. So I wanted to show you the kind of security preparation that you would have to do to use PolyBase to access data from an external data store. So let's do that. So we've created the first component in PolyBase. Now we tell it the structure of the file, and we tell it that the format type is delimited text, the format option is field terminator of common, and a string limiter of quotes. So we'll run that. You have now defined the two core objects that PolyBase is required to create the table structure, the external data source and the external file format. All that's left to create now is the external table that will stage that data in memory. We do this by creating what's called an external table. Note at the bottom of that SQL statement, the location is a whack. That's saying the root of your data source. Look at the data source. It's called Azure Storage Product. That was the object that we've literally just defined. Look at the file format. That's called text product. That is the object that we have literally just defined. Everything else within there in the create external table is basically defining the structure of your table. Now you could, if you wanted to, define some, transformation logic in the T-SQL statement itself, right? There's nothing stopping you from doing that. What I generally find, though, at this stage, the people are just loading the data. They're just landing it, yeah? So let's execute this. This will take a few seconds. Now, the idea is that an external table is basically persisted in memory, which basically means that you then create your actual physicalized external table within the database itself. So we can basically run queries on that table, right? So we could do a select from, we could do a count. I tell you what, I'll just do one of them. So this at the moment is just doing a select from all the table. And this will give you the structure that we've defined. There you go, product key, product name, so forth. Now, the way we finalize loading that is we will create a table in the DBO schema called products. It's going to have a clustered column store index with a distribution of round robin. You will learn what round robin is in the next session. And here's the key point. It's as a select from the DBO product external table that we've literally just created. So from that, we've got our external data source. It's just taking its time to update. What I'm trying to show you here is that the objects that you create for PolyBase reside in these external resources folder. I'm not going to open up the other one, but there's your storage products. Go on, let's open up the other one. Your text files in there, text products in there as well. But you'll see in here that we'll have a table called dbo.product that's been created as a result of doing that load. And if I do a select top 1000, that's going to run that, bring the results back, yeah. But as I mentioned, you'll want to create the statistics on top of the columns that have that are queryable, basically. You're going back to, you know, statistic index management on your columns that facilitate quick query processing. Okay. Any questions so far? Sir, can I ask you very kindly to go to this microphone here for the benefit of the audience? Because I've got a big voice, but I think I would... Last time I played something this big, there was 2,000... Yeah, I was in a band.
Hi. So the usage of the key, is there a possibility to use the key vault for that?
Could you repeat the first part of your question, please?
So, the key you used for the connecting to the storage account, can you use the key vault for using that key?
Yeah, so can I use key vault to store the key that I've just used? Absolutely, yes you can. And that provides a more secure way of actually managing your keys there. So great question, yes. Yes, sir.
What's the use of external tables?
What is the use of external tables? They are used to load data into Azure SQL Data Warehouse. So what an external table is it's data that's in memory. It is not stored anywhere.
Okay.
Then you use the create table as select method to take that data and persist it, physicalize it within the data warehouse.
Okay, the actual tables are the physical tables and external tables?
Yeah, the external table is not physicalized.
Okay, sure.
Okay. Any other questions? Could you please come to the microphone? This is the demo completed, right? So there's nothing left to show. So at this stage, I'm just going to answer the questions at this point. And that was another piece of feedback as well, which I really appreciated getting that. Yes, sir?
So what's the performance difference in querying external tables versus regular tables?
What's the end game? What are you hoping to achieve apart from go faster? The thing is that external tables aren't physicalized, so it's only going to be valid for that session. Your intention with this is to persist that data into a physical table for use of descriptive analytics. With Synapse, we make it easier to facilitate that with advanced analytics as well. Are you talking low performance? Or are you talking query performance?
The latter.
The latter. The only reason you should be querying the external table is for the load. Users should not be querying external tables. They should be querying that. So basically, external tables are naturally going to be quicker because they're in memory. Yeah? Whereas the physicalized tables are distributed across the compute nodes. What we'll learn in the next session is how we can optimize that through the various distribution predicates that we can use. Does that answer your question?
Yes.
Okay. Yes?
So in the previous session, you had shown to use Azure Data Factory to copy data into...
Perfect. Yeah.
Why wouldn't we just continue using Azure Data Factory and create a connection to the SQL data warehouse?
I am so glad you reminded me. That was the whole point of this session, right? It's all well and good me doing all this code, but you're not going to do it. Just use Azure Data Factory. Put a tick. When you do that enable staging, it does all this for you. So with the click of PolyBase in your sync properties and enable staging and choose your staging location, you don't have to worry about the data source, you don't have to worry about the file format, you just have to worry about the structure. So thank you for asking that question because you reminded me of the most important learning point in this. Use Azure Data Factory to manage your loads into the data warehouse with the PolyBase options.
Yeah, because if you want to automate, that will be...
Precisely. But I did when I sat down and thought about this session, right, I did think, well, we're going to be doing the PolyBase on the Wednesday through ADF. I wanted you to see what the work is behind the PolyBase so that you understand what's going on. So hopefully from this, if you've been to both sessions, the last session you would have gone, well, you know, Daniel just clicked on this PolyBase and it just seemed to work. Well, actually what Daniel did by clicking that is all this code that you're seeing here. So hopefully that gives you the context.
Okay.
Does that answer your question?
Yeah.
Thank you.
Thanks.
Yes, sir.
So is an external data source just like a temp table?
That's the analogy I would use, yeah, because basically the persistent memory for that session.
Okay, and then of all this script that you ran for the first time, what if you want to run a second load? Do you rerun the whole thing or just pieces of this?
Yeah, so what happens when you want to do a second load of data, the third load of data, this is where within the mapping data flows there are actually transforms that manage that through this. So you've got slowly changing dimensions and so forth at the click of a button. So yeah, you wouldn't manage it through this. You could do with the typical techniques that you had for managing data warehouses in SQL, right? So, you know, having a column that was marking the last update time and so forth. But with ADF, you've got it there.
Is this practice best for initial load only?
Yes. This is really good for initial load. Yeah, great point. Okay, well, we have just less than 3 minutes left. Has this session been useful for you? Yeah, is there any final questions? Could I ask you to go to the mic at the front, please?
Hopefully this is a simplistic one, but you went through and did the initial loading earlier on this week using Data40. Yep.
Yes.
I've got my source, which might be an on-prem relational database.
Yeah.
My destination, SQL data warehouse, because I'm migrating data up into the cloud.
Yeah.
Should I extract my on-prem data into Azure Blob Storage, and then go, so it's taking effect of the PolyBase stuff, or can I go point to point?
That is the pattern I'm definitely observing with customers, and it's one that we're recommending.
But the point-to-point pattern, or the output to...
Yes, so the output of your on-prem goes to a store, and then you run the PolyBase from the store into SQL Data Warehouse. That is definitely the recommended pattern.
Excellent, thank you.
You're welcome, sir. Thank you very much. Okay, then on that basis, hopefully I might see you in an hour's time. I am available to answer questions offline here. Thank you so much.